Hi, I'm Bartosz Ludwiczuk. Me and the second Bartek, we are research engineers at Allegro. Today, we're going to talk about the challenges in developing visual search system at Allegro. More precisely, about the dataset creation and deployment pipeline, as both topics were not straightforward as we anticipated. First of all, let me introduce you a visual search engine. The general idea is to enable users to search offers by taking a photo or screenshot of any product they are looking for. As sometimes it's just more convenient way, or users have the doubts about what should be typed in the Allegro search bar. Visual search engine is available for all registered users in the mobile applications, both Android and iOS. Currently, we support half Allegro offers, including the most popular one, Home and Garden and Fashion. Now, let's move to the first topic. The first part of the presentation will present the pipeline for the artificial dataset creation for training the model for visual search engine. Let's start with explaining what kind of data do we need to train the model. Our main idea is to create the embeddings from an image and having an index or all available offers while searching for the nearest neighbor. Using machine learning nomenclature, we are using the metric learning approach. We train our model using the pair of images, the label that states if the current pair is positive or negative. In the case of the positive pair, loss function is trying to attract embeddings from both images. In the event of the negative, loss function is trying to repulse embeddings from both images so that they would lie in the different area manifold. Our aim is to generate a dataset which consists only positive pairs, as negative pairs are taken from the other examples within the batch. Now we need to explain why do we need to create an artificial dataset for visual search. The story begins with the user interaction metadata. Here we have the query from the user and the recommendation generated by the engine. The user preferred fair recommendation and click it. As you have such information about the click in the metadata, we can gather them and create a training validation dataset. Imagine that we would like to include the new category in our recommendation engine, like supermarket, which wasn't supported by visual search engine at that time. How to gather the data for Allegro category, which is not available for the users. We created artificial dataset in the semi-automatic way, which resemble these user interactions. First of all, we define some requirements, taking into account both user behavior and our source database. The slide presents two interactions. The most prominent thing is that 80% of the images from a given example have a white background. A white background is recommended in the majority of the departments. However, user can send both photo or screenshot. We decided to distinguish two types of pairs, named street shop and shop, where shop means white background and street non-white background. Then both types of pairs are required during the training the model. The second requirement is about the facilitating the training process by removing the noisy data. In Allegro, we can find some product in many offers. Creating pairs from all available offers will deliver us a lot of noisy negative pairs. To explain the problem a bit better, let's take a look on the batch of images, which consists of 3 pairs. The green lines contain images which are supposed to present the same product. The red lines present the negative examples. But what about these last 2 negative pairs? The images represent the same product, but our metadata failed to deliver such information. Such a pair can cause a false signal during the training of the model. We need to take care of this aspect in our dataset creation pipeline. As mentioned before, the training dataset will be collected in the semi-automatic way, without any labeling level. However, such an approach should not be applied to gather test set, as otherwise we could just fit to the noisy data. So we decided to label each pair to select the test set. But still, going to collect those pairs. First of all, we decided to choose 5% of generated pairs as our test set. Additionally, thanks to Allegro Lokalnie, where users are listing the items, the real photos, we gather additional pairs. Some of the offers have a link to the product database. By connecting the user and product image, we collected approximately 10,000 pairs for each department. And finally, we label them by hand. So our test set is ready to use. As we'll be working with the data creation pipeline, the first step will be setting up the baseline without using any Allegro specific data to enable us to estimate the gain from each of the presented methods. Our first requirement was about having both types of pairs. Then we need to classify the images from Allegro offers so that we could just identify the shop and street images. Merchant also lists many images that are useless for us, like detail or multiple product, which we are ignoring in the dataset creation step. For this purpose, we trained a classifier with the 6 categories. Having such information, we can start the process of generating the training dataset. Our first source is Allegro offers. At the beginning, we gather all images from the selected offer. Then we run our classifier to extract the image category. And useless images are removed. In this example, we managed to generate 2 pairs of type street shop from a single offer. However, the presented pipeline has some drawbacks, like offers with a single image, a common situation in Allegro database. This issue can be mitigated by using another source database. Here we use the same tree, like for the test set, so using the product database. Then for offers with association with any product, the number of the images in a single offer increased to 2, what is sufficient enough for creating a single pair. After all this step, let's take a closer look at the generated pairs. The exemplar training pairs resemble this testing one. It seems that we chose the correct direction. However, after analyzing them, too many issues were discovered. The first issue is related to the second requirement for the dataset creation process, where we'd like to prevent from creation this noisy negative pairs. Presented pairs come from different offers, so our current pipeline does not guarantee this requirement. We decided to run the duplication algorithm for our training set to eliminate duplicate images. And perceptual hash was chosen as our image descriptor, as it's efficient enough for the duplication step. Then, for each image, we calculate the p-hashes. As the duplication method, dbScan clustering was used. The idea behind it is just to cluster together those similar images without selecting the number of the groups. Then, after the clustering step, the single instance from each node is taken, which is equal to removing the duplicates or near duplicate images. Such pipelines generate a clean pair dataset. The second issue relates to the quality of the pairs. Even if images have the correct types, there is no guarantee that images in the pairs represent the same content. This is mainly due to the merchants who include all kinds of images in their offers. We decided to use neural network embeddings to filter them out, as using perceptual hash leads to removing a lot of valid pairs. For each image, we extract the embeddings. Those embeddings are obtained using the model which was trained on weekly annotated data in the whole Allegro, so there is no direct bias in that model. By comparing embeddings within the pair, we get the cosine similarity scores. Here is the histogram of the all collected cosine similarity. Notice that, despite the duplication pipeline, many pairs result in the high similarity scores. On the other hand, we also analyze the second side of the histogram to check what kind of pairs get low scores. There is an example of the low score pairs. It's clear that they have nothing in common with the user interactions. We decided to set up 2 thresholds for eliminating both noisy pairs and too easy pairs. The range of pair similarity used for training is between 0.3 and 0.9. And removing the noisy pairs result in the final training dataset. These steps are applied for both offer and product-based datasets. Training on these domain-specific images is a huge jump in our testing scores, adding 26% to our ImageNet baseline. After including the product images in our dataset, we could get another 6%, so adding more data seems to help our model. But there is a second limitation in our pipeline. Offers that have only shop images prevent us from creating the main type of pair, I mean street shop. We decided to generate images with the synthetic backgrounds, which would mock up those street images. On the right side, we have an example of an image from our pipeline. But here, we need to make a couple of decisions about the methodology. The first question is about the changing the size of the source image by introducing some rotation, translation, or resizing. As by simple pasting, we could just get pixel level agreement. The results from this experiment are inconclusive, so in fact, we always test both of them. Another question is about how to paste the object on the background. Pasting them as a raw pixel generates unnatural images with visible boundaries between the object and the background. Here, the work from Carnegie Mellon University take a closer look at that problem, with the conclusion that having multiple methods for pasting and choosing them randomly yields the best results. We have chosen three methods: raw pixels, seamless clone, which take into consideration the background texture, and Gaussian blurring clone, which smooth the corners of the cloned object. From our experience, if the results are imperfect, like presented in the slide, they still help of the generalization of our trained model. Another question is about the type of the background which should be used. Two main scenarios were investigated. The first one is about the taking a photo in the white, for example, in the room, in the front of the building, anywhere. We call them natural images and can be obtained from the open images repository. The second scenario is about that making a photo on the uniform background, like floor, wall, or even lawn. Opposed to natural images, here, each image was chosen by hand, so you have the full control over the quality of this background. After testing both scenarios, we chose the uniform texture images as our background one. Our main conclusion was that hand selection of each background was the most crucial part. Taking random images from the open image repository introduced a lot of noise caused by non-constrained images. So our final score, the whole pipeline, is 70%, which is a huge rise over the ImageNet score. In summary, our dataset creation pipeline seems to be a good approximation of user behavior. It enables us to scale visual search engine to the new Allegro departments without having any real user interactions.
Hello, everyone. In this part, I would like to talk about how we expanded visual search to work on over 50% of Allegro's offers. We'll start with a quick description of our first deployment, which supported only fashion items. As you can see, it can be simplified to two models and a database for retrieving results. When the user sends the photo, it is first run through classifier to check if we can handle it correctly. This model classifies items into one of 12 departments with some examples above. At the beginning, we didn't support too many categories in Allegro, so most of the queries were classified as unsupported department and returned an appropriate message. However, when a photo was classified as a fashion item, we could proceed to the next model, the embedder. Its goal is to represent any image with a 256-dimensional vector. Both classifier and embedder are CNNs. The next step is to search for similar items in the database, which basically is a large mapping from image embedding to its original offer. We can compute cosine similarity between users' photo embedding and embeddings in our database. With that, we can now return the most similar offer, and hopefully it will be the same item as requested. In the presentation, I usually restrict myself to returning only top one image, but in reality, we return far more results. Okay, so let's go beyond fashion. As brought up before, there are 12 departments in total, and the first iteration supported only fashion. To increase the supported offer range, we started experimenting on 2 additional departments, health and beauty. We started by creating additional datasets for health and beauty in a way Bartek described in the first part. In our first approach, we decided to combine these datasets into one and train an embedder on the merged data. The model was evaluated on separate datasets from these departments to know how well does it perform in different domains. We also wanted to test another idea of specialized models. After gathering the data, we decided not to merge it, but instead of training a single model, we trained a separate specialized model for each department. We kept the same validation dataset as before for comparison. We found out that specialized approach has higher accuracy scores, so based on this result, we decided to follow that path. This is how our deployed pipeline looked at that moment. On top of the previous design, there's an additional branch with specialized model for whole health and beauty, and an index containing all offers from this department. We could handle both the fashion images with an original pathway, as well as health and beauty items with the new model. Unfortunately, we faced a new problem. Recent examples show the case when a classifier is sure about items category. But what if it's not? Let's say both departments have high probability. We still might want to return some results. In such case, we returned results from both paths and mixed them together, so we had a higher chance to find requested item. However, there's no simple solution to rank the offers, as similarities come from different models and cannot be directly compared. We could try some heuristics based on probability, but for now, let's stick with alternating categories. Okay, so we now support fashion and health and beauty. What's next? For the follow-up, we chose 2 additional departments, supermarket and culture and entertainment. Since our previous tests had pointed towards specialized models, we stuck with the same approach. Training new models was straightforward in this way, and deploying to pipeline looks a little crowded, but as long as it works, that is not an issue. But did it work as we expected? Turns out, not really. For example, there were a lot of classification issues. Mainly classifier had a large bias towards culture and entertainment. Maybe some full labels or boxes reminded it of book covers. There is also a problem with classifier training. The raw dataset is imperfect, as the same item or similar ones can occur under different departments in Allegro. For example, similar t-shirts can be found in a variety of places and therefore provide inconsistent signal for learning. Another problem was an underperforming supermarket model. Turns out it didn't work as good on large Allegro index as it did on our smaller validation datasets. One more issue was mixed results. When classifier was uncertain, we got a lot of unwanted offers that worsened user experience. Well, we had to quickly fix it. We decided to give the common model approach one more try. So we're back to the familiar setup, familiar training setup for 4 departments now. Turns out this time, models actually benefited from cross-domain data. We observed an improvement in almost all of our data sets. This way, we also addressed many of the mentioned problems. You can see that, firstly, the classifier has easier job than before. Also, the model improves performance on underperforming domains. What's more, we can now rank all the results as they are produced by the same embedder. One question that arose during all these trainings was, are we validating correctly? Well, let's consider the following setup, which is one we actually tried using. We've got a separate model for fashion and a joint one for other departments. In our pipeline, there are multiple validations. Each embedder is validated on the datasets it supports. Additionally, we validate the classifier on its own set of data. As we can see, there is no direct communication between the models and everything is validated separately. That's not good because there are actually multiple points of possible failure in our pipeline and they all accumulate during processing. First error we can encounter is a misclassification which prohibits pipeline from even searching the correct index. Even if an item is classified correctly, the pipeline can still return wrong answer. Last but not least, we can return correct result, but due to ordering, it can fall out of the top 5 propositions we're using for validation. A more fitting validation was needed. To face this issue, we developed an end-to-end validation pipeline that tries to mimic our production and helps battling previously listed problems. As you can see, the validation data is run through the small-scale copy of our production setup, where many of the real-life errors can occur. The main difference is that we do not use the entire Allegro production database, but rather than that, we create smaller ones from validation data. Each of them contains only images from offers that match its supported offer range. They are, however, often still larger than individual validation datasets for each department. During training, we fix all the models except the trained one, which is replaced with its current version every epoch. We can monitor a validation curve thanks to that. The solution is quite robust and can also be easily used during classifier training. When we compare a single model approach with the one with 2 models, one for fashion and one for the other 3 departments, we can see a huge difference for some data sets in favor of single model. This is not the case with standard validation, which shows only slight differences between the solutions. So to finish up my speech, I'll just quickly show you how easily are we enlarging now the offer range. So lately we included home and garden in the supported family. And starting from previous data sets, we attached one more for home and garden. Again, trained a single embedder while constantly validating it with end-to-end model. It allowed us to make a decision if we want to proceed with it to production, and that is exactly what we did. So deploying it on production is as simple as changing the mapping for home and garden after classification to be supported. And of course, we still need to replace the embedder with a newer model. Like that, you can now search a lot more stuff on Allegro with visual search. Okay, so a small ad at the end of the presentation. If you want to work on interesting projects and do research, like the work presented today or any other topic you can think of, apply for research engineer positions at Allegro. We'll be happy to hear from you. Thanks for your attention. It was a pleasure to have a talk at this Ghost event. Thank you again, and bye.
Hi.
Hi.
Hello.
The first question is, there's no much difference between the accuracy of the joint model and the specialized one. How do you explain the increase in the accuracy of the specialized model?
Okay, So we believe the main cause is basically the difference between the two domains. And I mean here the fashion and health and beauty are inherently different types of departments, and there is not much similarity between the offers. So when we are constructing our batches, we usually try to fill at least part of it with some hard negatives. And when we are enlarging our data sets, we're basically mixing them together. That might result in a larger amount of easy negatives from this largely different domain. And that probably results in a weaker signal during the training. And if we keep the number of epochs the same, it's basically we lose a lot of time, lose a lot of information during this training. And maybe I'll add that if we add some additional data sets later in different departments, it actually helps a lot. And the good example is supermarket and health and beauty. And these two data sets departments contain a lot of boxes, and they are probably chosen a lot more as hard negatives even between these two departments. And the improvement is really noticeable. Okay.
Mm-hmm. The next question is, have you noticed any concept drift in your data? If so, how did you deal with it?
Okay, so about the concept drift, I would say that we didn't detect anything special about that, but the real idea is more about our domain, I mean the image domain. The image domain, I mean the users are doing the images all the time in the similar fashion. I mean there's some background or something. So we didn't detect any special, I would say, data drift or concept drift in our data set. The only thing that in the beginning, when we just upload our first model, the fashion, our first thought that was all of the user would be just sending the images with this natural background, not the screenshots, yeah? And this is, and in fact, we were preparing model at first, just this natural background as the query and the white background as our offer store. But then I would say that we just analyze the data, how it looks like, how are the metrics. We also have this model that we are detecting this type of the image. So just pure, I would say, data statistics. We just get okay that this type of image is okay. There's many of them. I would say the screenshots, and we just deliver more and more images of this type in our training data sets. And this is how we deal it with this one, concept drift, but it's just a small one. In the longer period of time, there is nothing. We didn't meet any problems with this concept drift, in fact.
Mm-hmm. Next question is, how popular is this feature on the platform? How often is it used?
Okay, hard. I don't know exactly the numbers to be true, but in fact, this feature was released in the 1 year ago, something like that, and it was increasing without, to be true, in the beginning with any advertisement. But then if I'm increasing the new categories like home and gardens for market, this is increasing, and now but it is something I would say 100,000 interaction per month or something like that. Yeah, maybe even more, but this is like this number somehow.
Mm-hmm. Did you consider asking the customer what is the category of the product in the picture? It could be a workaround for the issue of conflicts between different departments.
So yeah, I think that actually might be a good idea. But the problem with Allegro, as I mentioned, is that its category tree is really tangled, complicated, I'd say, and sometimes you don't don't have any idea in which department you would like to look for. Of course, there are some simple cases like at least this, let's say, researching for some dress. It's most likely in the fashion category. But like now, there is really no need for that because we're sticking with this single model approach. And it's only, we only classify whether the item is supported or not supported. And we actually allow user to search anyway in our database if the classifier decides we do not support it. And this is the possibility for a customer to find this item even if our classifier was mistaken.
Mm-hmm. The last question is, did you consider extending datasets with the street images from the users? For example, uploaded in reviews of the offer?
In fact, yes, we're working on that topic, but to be true, there are not so many reviews in the Allegro. I mean that the scale of the dataset which we are currently working on is something like the 10 millions of pairs, a pretty huge one. And we can just gather from reviews, let's say even 20,000 of images. In fact, in our current approach, we are using these review images, but only for the validation of our model. I think that is just a more cleaner data set. We are sure about that the review is mostly connected to the product, but it's the only way we are using currently these review photos.
Mm-hmm. That's all for the questions. Thank you for your presentation and answering our questions. Is there something you'd like to add?
Yeah, so first of all, thank you for having me. It was a kind of new experience for me also. And I really enjoyed the entire format on the Ghost Day. I think it's a great conference. And well, a message for all of the viewers. Allegro is recruiting, as I've said already, and you probably can find a few different offers on the platform. And there are a lot of different research areas in our company, and you're welcome.
And the other Bartek?
Yeah, I think that Bartek said everything that's needed to be true. I also thank you for being here. And great that Ghost is rising, more attenders, more speakers. I'm happy that it's rising so much.
Thank you.